apply the distance and midpoint formulas. So in Algebra 1, and then again in geometry, we work with both the distance and the midpoint formula. So keep in mind, these are for ordered pairs for the points x sub 1, comma, y sub 1, and x sub 2, comma, y sub 2. So two ordered pairs in a coordinate plane. The distance formula is d equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Now remember that the distance between 2 points is really the same thing as the length of a line segment connecting them. So this can also be used for length. And we'll just make a note of that. For our first example, we're going to look at classifying this triangle as scalene, isosceles, or equilateral. So first we need to go back and review what these words mean. So equilateral is probably the easiest one for us to remember. That means all of our sides are equal in our triangle, so all three sides are equal. Isosceles was when we only had two equal sides. Scalene is when we had no equal sides. So remember, with our distance formula, we wrote down that it could also be used for length. And so that's really what we're going to do here, is we're going to use that distance formula to find the length of these line segments that are the sides of our triangle, and then we're going to classify it based on that. So first, I'm going to look at the length from D to F. So if I'm going to find that distance or the length of that line segment, then instead of my little d equals, I'm going to write df equals, because I'm doing my distance formula. And in order to use that distance formula, I have to have ordered pairs here. So let's see, d would be at -3 up 3. So -3, 3. And f is at -2, -2. So I have my x1, y1, and I have my x2, y2. So now I need to go ahead and substitute these into my distance formula. So distance formula, we do x2 minus x1. So square root of, don't forget the square root, -2 minus -3 squared plus, and then y2 minus y1. So -2 minus 3, the quantity squared. So let's remember that -2 minus -3 would just be plus. So that means we've got -2 plus 3 would be a 1 squared. And then this would be -5 squared. And I have to keep the parentheses because I need to square the negative and the 5 all together. I can't just square the 5 and then make a negative afterwards. So this will be the square root of 1 plus 25. And so we get that df is equal to the square root of 26. So let's go ahead and look at the next side on our triangle. So now I'm going to look at DE. So you might be thinking that you have a different or an easier way to solve right now. This should really seem a lot like the Pythagorean theorem. So let's think about the Pythagorean theorem. Pythagorean theorem, if you recall, is c squared equals a squared plus b squared, where a and b are legs and c is the hypotenuse. So if I wanted to get c by itself, I have to square root both sides. And then normally we would have an absolute value and we would have it equal to plus or minus. After we square root the c squared here, this is where we'd have the absolute value. But because we're working with a triangle, and it's something that's real life, we're not going to have a plus or minus answer. When we're looking at the length or the distance between something, we're always going to be looking at a positive value. So we have c equals the square root of a squared plus b squared. So this is basically what we're doing. When we're finding that distance or that length, it's this hypotenuse right here. So I could go ahead and kind of sketch in a triangle here that would be created so that DE was my hypotenuse. Here would be my right angle right here. So instead of going through and doing the distance formula, if we've got something on a graph like this, we could also just do the Pythagorean theorem. So let's go ahead and do that for DE. So to find DE, instead of subtracting to find my x side and my y side on this, I could just go ahead and count. So I have 1, 2, 3, 4, 5 squares for my x side of this triangle. So instead of subtracting to get that difference and find out the length of that side, I can just count them. So I'll have square root of 5 squared plus, and then I need to worry about that other leg, which is the y side in this triangle, and that's going to be 2 units long. So 5 squared plus 2 squared. So we'll have the square root of 25 plus 4, which is the square root of 29. So they are definitely not the same. It's not going to be an equilateral triangle, but it could still have an isosceles, so I got to keep working. So now I want to go ahead and find this side on my triangle. So we have options. We could do distance formula again, or we could do kind of that simplified Pythagorean theorem version. So I'm just going to look at Pythagorean theorem again because it is faster when I've got a graph. And on this side, my x leg of my triangle is 4, and then my y side or leg is 3. So I'm already getting the answer without having to do any work. I'm remembering that Pythagorean triple from geometry, that we have these 3, 4, 5 triangles. And so if my legs are 3 and 4, I know that my hypotenuse is going to be 5. So right away, I know that EF equals 5. So now to answer the final question. I have no equal sides here, and so I have a scalene triangle. For example 2, it says use the given distance D. So they're giving me the distance this time between 2 points to find the value of y. So I'm going to go ahead and label this first point my x1, y1. My second ordered pair, I will label x2, y2, and I have D. So I'm going to be using that distance formula, but this time instead of solving for D, I'm going to be solving for this y value over here. So let's go ahead and just write the formula out first. D equals square root of the quantity x of 2 minus x of 1 squared plus the quantity y sub 2 minus y sub 1 squared. So I'm going to plug in everything I have. So I'm going to substitute 2 square roots of 10 for D. And then I'll have the square root of negative 1 minus 1 squared plus, then I'll have 3 minus y squared. So now I have just one variable. I have to figure out how to solve that. So in order to get to this variable, I'm going to have to get rid of that square root. I'm going to have to move this stuff over and away from it. And I'm going to either have to expand this binomial or take a square root. I'll have to do something. So I'm going to start by squaring on both sides. So I know that the square root and the square are going to be inverses. So over here, my square root will be gone. And I'm going to go ahead and simplify. Negative 1 minus 1 would be the quantity. I guess it would just be negative 2 squared, but we have to have parentheses. And then I'm going to leave my 3 minus y squared for now. I'm not going to expand that out. When I go to square this side, I have to square the 2, which is going to be a 4. And then when I square the square root of 10, that just gives me a 10. So right now I have 40 equals 4 plus the quantity 3 minus y squared. So I'm going to go ahead and subtract 4 on both sides. And now I am going to square root both sides. So if I had expanded this, I could subtract the 36 so it was equal to 0. I could refactor. But because I already have a squared quantity isolated and I have a number that I can easily square root, I'm going to choose to square root both sides instead. So this now is not looking at something that's just going to be a simple length on a triangle. So I could have a negative or a positive value for y. That would make sense. So I'm going to have an absolute value. And then the square root of 36 is just 6. So now I need to go ahead and write out 2 inequalities and solve them both. Either 6 will equal 3 minus y, or negative 6 will equal 3 minus y. So we'll have to subtract 3. And I like to solve them both at once. And then I am left with a negative y. So we'll have to change our signs also. So our answer is that negative 3 is equal to y or 9 is equal to y. Next, we're going to look at the midpoint formula. So midpoint formula, again, is for 2 points on the coordinate plane, x1, y1, and x2, y2. And in order to find my x midpoint, y midpoint, I need to take my x's and add them together and divide by 2. So I'm really finding the average of my x's. So think about if I had 2 test scores, if I had an 80% on one test and 100% on the other, and I wanted to find my average test score, I would add the 80 and the 100, and then I would divide by 2 and get 90. So we're doing the same thing here. We're trying to find the middle value, and so we add them together and we divide by 2. So x sub 1 plus x sub 2 over 2, and y sub 1 plus y sub 2 over 2. Another way to look at this formula that's helpful sometimes is to kind of look at each one by itself, kind of isolated. So if I am looking at just my x midpoint, that's going to be equal to x sub 1 plus x sub 2 over 2. This is really handy when they give you the midpoint, but you're solving for one of your x's you had to start with. And then my y midpoint would be equal to y sub 1 plus y sub 2 divided by 2. So sometimes it's handy to look at the formula that way instead. And a lot of people don't know you can break it up that way. So it's kind of nice to have that on paper and remember. For example 3, we got kind of a multi-step problem here. It says we're going to write an equation for the perpendicular bisector of the line segment joining A, which is at 5, 4, and B at negative 1, 6. So whenever I get a problem like this, the first thing I want to do is sketch it out. So A is at 5, 4. So here's A. And then B is at negative 1, 6. And I'm going to connect that line segment as best I can. And then a perpendicular bisector means I'm going to be chopping this in half, basically. It looks like it could be about there. And I'll be drawing a line through that. And the line will form a right angle. So it's going to be equal on both sides of that. Remember those little tally marks or little marks that we make from geometry? So not only is it going to be chopping that line segment in half, but it's going to form a right angle when we draw that line. So we're looking at the equation for this. Equation for this. That's what we're looking for. So the directions here are kind of walking us through that. So if we're going to find the equation for the perpendicular bisector, first we need to find this point where they're bisected, because that would give us a point on the line. So in order to find that point, we need to find the midpoint of AB. So I want to find my midpoint. So I'm looking for my x midpoint, y midpoint. It's not really necessary to write that part down, but I think it's good just keeping what we're doing right now so you remember later on. We always put extra detail in our notes. So I have to take my x's and add them together. So 5 and -1 are my x's. And distance formula has a minus sign, but remember now we're averaging, so we're adding them together. So 5 plus -1 divided by 2. And this is an ordered pair, so I'm using parentheses. And then I'm going to take my y values, my 4 and my 6. And again, I'm trying to find the average. So I'm going to add them together and divide by 2. So now I have 5 plus -1 is 4 divided by 2. And 4 plus 6, 10 divided by 2. So my midpoint is going to be 2, 5. So that's my x and y. So 2, 5. 2, 1, 2, 3, 4, 5. So it's pretty close. It's right there. Not bad. My next step is going to be finding the slope. If I want to draw a line perpendicular to this one, I need to find the slope and then the perpendicular slope. So then we're going to go ahead and do the slope formula. So my slope will be y2 minus y1, so 6 minus 4, divided by x2 minus x1, so -1 minus 5. So my slope is 2 divided by -6, or -1/3. So let's go ahead and change pages. So my perpendicular bisector will have a slope that's the opposite reciprocal. So if my slope right now is -1/3, then my perpendicular slope will be the opposite. So instead of a minus, I'll have a plus, and we'll have to do the reciprocal. So the reciprocal of 1/3 would be 3/1. So that means the perpendicular slope I'm looking for is just 3. So we're going to use point slope form. For that, all I have to have is a point and a slope, and that's what I have right now. I have my slope as 3, and then the point we got on the other page was that midpoint. So for our point, we have a 2, 5. That'll be my x1, y1 in the point slope formula. And my m is 3. And just to review, point slope form is y minus y1 equals m times the quantity x minus x1. So this will give me y minus 5 equals 3 times x minus 2. And I do want to rearrange this and solve for y equals mx plus b. So that means I need to go ahead and distribute. And then we'll add 5 on both sides. There we go. Y equals 3x minus 1. So one last thing I'd like to do is just kind of flip back and see how this equation compares with my graph and just make sure it looks reasonable since I already have it graphed. So y equals 3x minus 1 means it would start here at -1 and then go up 3/1. And so that looks pretty darn good. It looks like it makes sense. You can go ahead and complete the 9-1 book assignment now.